My name's Dixon White, and I'm here to talk to you about whether to fly. Flying is an ultimate human realization. It's the leading edge of human potential. There's no doubt that almost everybody in mankind's past has looked at the sky and thought how wonderful it would be to fly. And now we have vast resources of different types of aircraft that we can use in order to make our dreams come true. But whether to fly is very important. And in this video, we're going to try to analyze where you should find information that will help you determine if the model is appropriate for you to fly in. We're going to show you how to get to the resources, how to use those resources to develop the data that you need to determine whether you should fly. This is an entirely new concept for many people. Looking at the air and trying to determine whether the air is working appropriately for them to have a simple flight or a complex flight, a flight where they get really high and stay in the air for hours, fly many miles. Treat yourself as a new pilot as though you're a very naive person starting to drive for the first time. The decisions of whether to fly really involve your ability to make some observations about the overall wind, the stability of the air mass, comparing those things to the exact terrain that you're going to fly, and then keeping in mind your particular skills. These things add up to whether to fly. And if you'll take advantage of the information you gain from this video and apply these things for 2 weeks, you'll find you'll have a slimmer, trimmer, more satisfying flight experience. In order to pursue this need for detail in developing your models of conditions that you want to fly in, I highly recommend that you have a barometer, and it's a barometer that maps the trends, whether the pressure has been going up or down. And you'll start to notice that if the pressure seems to be falling off rapidly or increasing rapidly, that it's not uncommon for that to indicate windy conditions. And don't fool yourself. Just because it's calm at lower elevations, but you still are noticing the barometer going up or down, there's a chance that you're in an inverted layer of air mass and that you could have a very spontaneous flow of strong winds as the inversion burns off. The sky. Geez, we're going to talk about that more in greater detail in a few minutes, and that's the actual art of studying the clouds themselves and trying to interpret some data off those clouds. The internet is a terrific resource. www.paraglide.com has a weather section which is extremely thorough and allows you to access a variety of different weather sources very quickly, easy to follow. 1-800-WX-BRIEF. There is a method at which you should talk to the briefer. When you call 1-800-WX-BRIEF, you need to identify yourself as a pilot and know exactly what it is you're asking for. You need to ask for surface winds through 18,000 feet, identifying the area that you're going to be flying in. You need to know the winds, direction, and temperatures at the different elevations. And if you ask them to give you that information in Fahrenheit, they're usually willing to do so. The 162 megahertz range on your radio is very useful for a continuous weather update information. It's not uncommon for them to announce wind direction and velocities, including peak velocities, that are anticipated throughout the day, and that is useful information. The Weather Channel is terrific, as is quite often the local news broadcast concerning the weather, so that you can identify a jet stream map, isobar map, a low and high map, indicating to you that conditions are either stabilizing or destabilizing with encroaching frontage passage. And you should have a wind meter, an anemometer such as this one here, And this particular one happens to have a barometer and a number of other features, temperature and so on. Very handy. And use the anemometer on your favorite site to actually measure what's happening with winds. In some parts of the country, there isn't much available in terms of local weather information from WX Brief or from the internet. Or if you're traveling outside the country, there may not be much information. And I found it very useful to take a helium balloon with me and to use the helium balloon in order to help identify the strength of upper level winds. By releasing the balloon, following it upwards, you can see what direction the balloon flows, and you can see at what rate of speed it seems to be moving along within that flow. In fact, a good pilot will start to see a trend of approaching weather conditions that make sense for their ideal conditions. Huge systems of air, thousands of miles in size sometimes, as they flow into your particular flying area, can have a powerful effect on the overall windiness. And you can find, using the internet, asking questions of the briefer through 1-800-WX-BRIEF, looking at the Weather Channel, your local news report, and even listening to NOAA Weather Radio. You can find out what's happening regionally with the overall winds. The regional air mass can be examined by looking at the jet stream and its proximity to the area that you're going to be flying, the compression of isobars in the area that you're going to be flying, and the isobars relate to pressure differentials. As a matter of fact, looking at your barometer, if you see your barometer on your watch or on your wind watch, whatever, showing changes that are quite abrupt, you can anticipate windy conditions, and where the lows and highs are. As we look at a weather map, many of them will display a jet stream. The jet stream is a very powerful piece of information for you to observe, because if the jet stream's right overhead or within about 100 miles of where you're going to be flying, anticipate the high probability of strong gusty conditions and maybe even what we call switchy conditions. In addition to the jet stream, we look at where the lows and highs are. The further apart the lows and highs are from each other, the more appropriate the conditions may be for flying in gentle air. As you start to see with the lows and highs, compression of the isobars, which are the fine gradient lines in between the indicators of lows and highs, those pressure differentials can mean very windy conditions. Within the website paraglide.com, we can go to the wind, soaring, and aviation link. So I'm going to go over to weather and double-click weather. So now that we're in the map section of the Weather Channel, we can go to the jet stream forecast. Okay, so here's our jet stream picture. And notice that the jet stream is pulling lots of cold air down across the state of Washington and Oregon. And with that, as we've seen today, we have multi-layered skies, a lot of cloud cover, very windy, gusty conditions. To the U.S. barometric pressure map. A very detailed isobar map with lows and highs present. On this particular weather map, where would the flying be good? Probably down here in the southwest, Southern California, Arizona area. We don't see a very tight isobar compression zone in here, nor do we see an actual lower high. Wind, soaring, and aviation links to the soaring forecast. And where it asks for mandatory information, guess what? They want that information. So you have to click on Complete Report and then go down to your area. And we can see that the standard adiabatic lapse rate or adiabatic lapse rate follows along this line here. But the actual measured temperatures graph out so they cross, showing that it's actually very stable. it is a really common event for there to be a layer of cool air next to the ground that hides the fact that there are strong upper level winds. And it's imperative that anybody who's going to fly relatively slow aircraft, and particularly non-powered aircraft, do a thorough check of upper level winds. If you don't, and that inverted cool mass of air melts away at some point during the day, you get to live with the fact that it's suddenly blowing much harder on the ground than you ever thought it could do. So we can find on the internet the winds aloft forecast for any region in the country. It gives a listing identified by cities that are abbreviated for the cities, in this case, the Rocky Mountain region. Now you can also call 1-800-WX-BRIEF and ask the briefer for this same information. Now then, the top line of the chart that we were just looking at shows feet in elevation above mean sea level. So we have 3,000, 6,000, 9,000, 12,000, and 18,000 feet above sea level. On this particular chart, we have Phoenix, abbreviated PHX. You can ask the briefer for your area what the abbreviation is for the city closest to you, so that when you look on the Internet winds aloft forecast, you'll recognize the particular abbreviated city that you're interested in. These numbers are really very simple to decipher. At 3,000 feet, Phoenix is showing from the balloon that was lofted in the morning or in the evening. Again, they loft a balloon every evening and morning from a variety of cities in order to get real data transmitted back to their weather station. And this balloon showed at 3,000 feet, 24 means 240 degrees at 13 knots. 240 degrees would be southwest. 0 is north, 90 is east, 180 is south, 270 is west. So 240 is southwest at 13, and that's 13 knots. Knots are approximately 15% stronger than a mile an hour. So this would be almost 15 miles an hour. At 6,000 feet, we have 250 degrees at 17, and now it gives us a temperature. Now, this temperature is in Celsius, plus 17. So you need, if you're a Fahrenheit-oriented person, to make some calculations or use a Fahrenheit to Celsius table to recalculate the temperature in your own language. At 9,000, we have 260 degrees at 15 knots, 9 degrees Celsius. At 12,000, 260 degrees at 19 knots, 4 degrees Celsius. And at 18,000, we have 260 degrees at 34 knots, minus 8 Celsius. If we happen to see a 99 on this chart, then that indicates that the winds are actually light and variable. If you were to see on this chart a missing set of numbers, that would mean that there was no information obtained at that particular elevation. Okay, now that we've looked at the jet stream, isobar maps, lows and highs, temperatures aloft, winds aloft, and at a lapse rate graph, I think we have quite a bit of information to work with. Unstable conditions mean that the speed at which heated puddles of air on the ground leave the ground and climb upwards can be extremely violent. Now, if you find the perfect day, you have thermals leaving the ground, climbing at a reasonable rate, and acting softly for the pilot to enter into and track as they gain altitude. And because of the high pressure, the thermals that build and then release are extremely small in size, have extremely sharp edges to them, and your entry in and out of those thermal columns or thermal bubbles can be very violent, really sharp-edged, and it doesn't make for that much fun of flying. So you want a mix of the right level of pressure with the right temperature differentials between surface and altitude. And we can actually map that type of stuff. You can make notes to yourself in your modeling of the atmosphere of whether or not the pressure is moderate, the temperatures aloft are within a certain zone, and you recognize that the terrain you're flying over accumulates a certain amount of heat. Stability is very important. You do not want to put yourself into a situation atmospherically where it is far less stable than what you're capable of handling. And on the other hand, if you're a good pilot and you're looking for the appropriate cross-country conditions, you probably don't want to take a day off work to go chase a day that's super stable. Now, you want to make note of, at different elevations, what the temperatures are. For example, you can find out from these different sources that we talked about what the temperatures are at 9, 12, 15, and 18,000 feet. And we can produce two very clear models from that. One is the lifted index, the second is the thermal index. Now, in general, air cools at a consistent rate of 5.5 degrees Fahrenheit per 1,000 feet, or 3 degrees Celsius per 1,000 feet. This green line represents that as you gain altitude, that air cools. When you plot temperatures as you climb in altitude that show that it actually isn't cooling all that much, that maybe the temperature actually isn't all that much colder up above than the 5.5 degree Fahrenheit per 1,000 feet, then you know you've got a fairly stable day. Now then, let's suppose that when you plot the temperatures that you gather from your information sources, you find that you have a day which actually has temperatures with dramatic cooling as you gain altitude, with the orange line now representing a dramatic enough cooling that you have a seriously unstable day. We've plugged in over here some real numbers in order for you to help think through the thermal index. Before we break these numbers down, let's take a moment and think about how a typical day, evolves. Let's suppose that the morning of a typical day that you want to fly, you take a thermometer and put it on a fence post, maybe 12 inches off the ground, 5 to 12 inches off the ground, so that you can measure what we call the puddle temperature. You're measuring what the temperature of the air mass is within a very close range to the ground. Now, if you put a thermometer flat on the ground midday, you might find temperatures as high as 130 degrees in some areas of the country. Raise that thermometer up 5 to 10 inches off the ground and you'll find a body of air developing that could be 100 or 110 degrees. Just because the Weather Service says that downtown temperatures are going to be 85 degrees, that does not necessarily mean that there won't be puddles of air accumulating over scree fields, plowed fields, dirt, so on. They couldn't be 20 to 30% higher than that. But in the morning, you might find that temperatures in your neighborhood, 5 to 10 inches off the ground, or maybe 60 degrees. So that means that in relationship to any one of these lapse rate lines that we've drawn here, that it actually gets warmer as you climb up in altitude. This area would be called an inversion because you have colder air down next to the surface compared to the warmer air 1,000 to 3,000 feet above the surface. But throughout the day, as the ground heats the air slightly above it, we might find puddle temperatures of then 70 degrees, and then 80 degrees, and then 90 degrees, and then maybe 100 degrees, or even warmer. Let's suppose that in fact at 2:30 in the afternoon we have puddle temperatures of 100 degrees. That means that there's an extremely sharp decrease in temperature from the surface to even just a few thousand feet above the ground. In our illustration, if we look over here, let's suppose that at 5,000 feet, which is your starting elevation above sea level, it reaches 100 degrees. We go up to 9,000 feet, which the Weather Service has reported to us as being 70 degrees. And we find that looking at the normal cooling rate of 5.5 degrees Fahrenheit per 1,000 feet, that actually the temperature at 9,000 feet to meet the standard model should be 78 degrees. But since in fact that at 9,000 feet the Weather Service has reported that it's 70 degrees Fahrenheit, we have a -8 in the thermal index. Let's look at the thermal index between 9,000 and 12,000. The Weather Service has reported that they measured temperatures of 50 degrees at 12,000 feet. Well, there's a 3,000 foot elevation differential between 9,000 MSL and 12,000 MSL, which means there would be a 16.5 degree normal cooling rate according to the standard dry adiabatic lapse rate. And so it's supposed to be 54.5 degrees according to that standard dry adiabatic lapse rate. But in fact, since they measured 50 degrees at the Weather Service, we now have a negative 4.5 degree Fahrenheit differential, and that gives us a minus 4.5 thermal index. Between 12 and 15, we have a 0.5 negative thermal index. 15 and 18,000 feet, we have a negative 4.5 thermal index. So we can see between all of these different elevations that there is a definite, strong negative tendency indicating a lot of reason for thermals to want to climb very high through this atmosphere. The lifted index specifically looks at the difference between 5,000 feet MSL, which is our starting altitude, and 18,000 feet. We see, according to what we had up here with our previous chart looking at the thermal index, that the temperature was 13 degrees at 18,000 feet, and our temperature at 5,000 feet is 100 degrees. The standard guide is 5.5 degrees per 1,000 feet. We have 13,000 feet of altitude differential. There should be a 72 degree temperature differential, but the fact is that we have substantially more than that, giving us a negative lifted index of minus 15. The model on this particular day is extremely unstable. This is a very strong day. If you are a newer pilot, or somebody that's a rusty pilot, or somebody who likes to fly in soft, more forgiving conditions, this would be the kind of day where you'd want to fly in the mornings before there's a substantial amount of heating. If you're a cross-country pilot looking for epic strong conditions, this model looks good. In this arena of looking at stability, let's summarize here. We have two indexes that really say the same thing. We can say that the lifted index and thermal index numbers tell you a similar story. And that is that a negative number is going to mean less stable conditions. So that a more advanced pilot is going to want to fly probably in more negative indexed conditions. For pilots that are looking for softer, more easygoing conditions, they want a 0 value to their index or a positive number. A 0 or positive number could be as high as whatever. With a negative number, in general, most soaring pilots that are looking for ideal thermal conditions prefer a -3 to maybe a -10 range. The K index, that range again is from 15, which would be an unlikely probability of thunderstorm activity, upwards to 40 plus, which would be extremely likely conditions for thunderstorm activity. Now, moving down here back to the chart that we pulled from the internet. Again, the internet provides us a wonderful tool for seeing with the green line the normal lapse rate, and then with this pink line showing what the actual numbers were for this particular day, indicating that it's actually a very stable day. And then we drew in here the orange line, trying to help you understand what an unstable day would look like. In addition to the information we've already covered, the soaring forecast available through the internet will tell you an anticipated time of first thermal release and the height of the thermals, in addition to the strength of the thermals. All of this information is very valuable, and you should be accessing this information and using it. It's not a bad idea to take the different pieces of information that we've been talking about and put your models together even on days when you're not flying. Check with the pilots in your club who are flying and find out what the day was like, so you can keep fine-tuning your model to find the exact kind of conditions you want for your next flying adventure. Okay, so we're ready to talk about clouds, or particularly the big black one that'll be hanging over my head if I don't get this stuff right. All right. You know, I'd rather not turn this into a terminology fest. I want to keep things simple. I think that what we do looking at the sky every day is really not all that complicated. So I'd like to review the simple cloud indicators that tip us off as to whether or not the conditions are going to be particularly good or questionable. So we're going to look at high clouds, cumulus, multi-layered clouds, virga and rain clouds, and talk about a fast sky. First of all, talking about high clouds. It's not uncommon for us to have wisps of high clouds move through an area called cirrus. You'll hear people refer to some of the high clouds as mare's tails. But something we've noticed that concerns us is when we have a nice blue sky, seems like crisp air, and all of a sudden, approaching generally from the west, a defined cirrus trough line. Upper level clouds moving into an area is not a happy sign. We'll correlate to that the barometer dropping. If you go in and call WX brief or look on a weather map, you'll probably see that there is some sort of prefrontal activity occurring. And with that dropping of pressure, the observable sky of these clouds moving in can come very switchy, gusty conditions at your flying site. And that may not be appropriate for pilots unwilling to take on tough conditions. Cumulus clouds are a result of thermals lofting warm, moist air. Now, there are many days that are very flyable that have no clouds whatsoever. In fact, you can fly for miles on completely cloudless days. But when we're graced with a day, the sky being peppered with cumulus clouds, they're flat-bottomed, nice and puffy. They aren't really any taller than they are wide. We have then a scenario where we can use those clouds to help us identify how the sky is developing, and it will help us move through the sky tracking lift that much more competently. You'll observe as you sit and watch clouds, and just really if you take an hour and watch clouds develop, cumulus clouds develop, you can see when a cloud is just starting fresh. In fact, if you keep watching an area where you see a cloud start up, nice and white and crisp, and then reach its full blossom stage of development and then start to decay, that it actually gets a bit of a dingy look to it, a yellowish look, and then it'll completely go away. But something we've noticed that I'd like to pass on is that if you keep observing that area, you'll probably start to notice a number of minutes before an actual cloud develops that that particular same spot in the sky may very well have a grayish, smoky sort of look to it. And that's a precursor appearance to the actual formation of the cloud. And when you're flying at altitude and using clouds in order to make a cross-country course, if you can start to identify that scenario in the sky, you can arrive that much sooner at the next spot where a thermal cloud is going to develop. After researching some data on the computer or talking to the briefers, we're able to chart out the cooling trend in the atmosphere. Quite often, if there's enough moisture in the air, the K index is happening for us, we can look at the actual clouds and see evidence of the cooling rate in the atmosphere. User-friendly cumulus cloud, the type of cloud that a cross-country pilot or thermal pilot is going to be interested in flying, is really not much taller than it is wide. A less friendly cloud is going to be more vertical. And then obviously in this case we have a tremendous amount of vertical development with a bit of an anvil head on it. It'd be silly to fly in these conditions. When you have charted the cooling rate of the atmosphere, you'll see that the more friendly circumstance, the less friendly, and then obviously the seriously scary air. Now, what numbers do you relate to this when you look at the thermal index or the lifted index? Well, we might see this type of cloud development with enough moisture in the air when we find a lifted or thermal index of -1 all the way up to approximately -5. And in this case, we might see this type of development in -5 up to -10. And then this would be more than -10. So looking at the lifted index and thermal index is important, and recognizing how much moisture in the air is important because it helps you identify whether it's going to be a blue day, where there's thermal development yet no evidence of clouds, or a nice cumulus day where the clouds are giving that cross-country pilot a terrific roadmap to a long-distance flight. Cumulus clouds are obviously user-friendly for the cross-country pilot because they can see development, but you can also reference upper-level winds and direction by looking at the cumulus clouds and their shadow. As that shadow tracks across the ground, it indicates wind speed and direction. And throughout the day, keeping track of that's important because it could be winds will start increasing and you may make some decisions about where to head next or maybe even head to the ground. So watch cumulus cloud shadows on the ground in order to determine upper-level wind direction and speed. When you start to see a combination of high clouds and lower clouds in the sky, and sometimes seeing even 3 layers of clouds, of high, mid, and lower level clouds, we call that multi-layered. A multi-layered sky is foreboding to me. That's a big word. But I am concerned about it, and as a teacher we certainly back off with our less experienced pilots when we start to see that type of sky appear. Maybe that means a phone call to WX Brief. Again, it ties to this concept of a cirrus trough line moving into the area, but even more so because the multi-layered sky indicates that there's a lot of activity in the atmosphere, that the atmosphere is destabilizing quickly, and it's possible quite often that you'll find a multi-layered sky resulting as the day progresses into a gust front situation where there is such a relief of pressure on the surface that the barometric pressure drops off so much that you can have a sudden spontaneous release of accumulated heat and a lot of surface flow of wind. That kind of wind being beyond what some of the aircraft we fly can manage. As the sky destabilizes, we can then develop rain clouds. In addition to virga and rain clouds, we should also list the type of cloud that has mamata. Mamata, rain clouds, and virga. Each of these are indicative of very serious instability in the atmosphere. And that's not a happy thing for most of us that are flying slow aircraft. Mamata, which is a very clear, obvious type of cloud, may be something that appears just momentarily before seeing rain actually fall out of that cloud to the ground. And don't fool yourself. Virga, which is high rain, that doesn't actually make it all the way to the ground, is deadly. High rain that evaporates before it hits the ground chills the air immensely. And as that air chills, you have a lot of cold air splashing to the ground and flowing outwardly. In fact, you could even have more of an outflow boundary from that virga than you might have with an actual rainfall to the ground. So it's certainly a condition to avoid, and I think almost all pilots will land when they see that type of situation. A fast sky is a sky where we can identify by seeing certain types of clouds that are indicative of high winds aloft. And those clouds have a variety of names. We have lenticulars, which are round, smooth, and clouds that actually look stationary. And these round, smooth clouds that can actually stack on top of each other or have a wave-like appearance to them over a number of miles are definitely indicative of quite a bit of high wind activity at that particular layer. And the reason that's not good for us foot-launched pilots or for pilots flying slow aircraft is because if it's blowing hard at altitude, there's a good chance that that upper level wind flow can make its way all the way to the ground. And you could have, within a few minutes, a day that seemed to be just wonderful turn into very windy conditions. In addition, as we look at the fast sky, we can sometimes identify cumulus clouds that are not well formed, and those particular clouds will shred, or you'll see them actually tracking through the sky. If you fix your eye against a roof line or tree line, you can see that those clouds are moving quite quickly. And you want to be careful flying in those conditions that you don't misjudge the possibility that you're flying in an inversion that will burn off later in the morning, and you end up with very strong winds on the surface that can appear within a few minutes. In a sea breeze situation, we have a body of water that is probably fairly cool in comparison to the surrounding land. As the sun heats up the land that surrounds the lake or the ocean, you have warm air rising above the land and drafting from the ocean or from the lake quite a bit of cooler air. And so you have a continuous flow of air on shore in this situation. Flying in those flatlands, we look for the material that we think will heat the most. Try to fly near that. If there are power lines going across those dark fields or a road, that can be a good sign for us, because those power lines or fences, the road that moves through the dark field, the plowed field, can be the actual trigger point of the heat that accumulates in that field. Or the break between the irrigated grassy field and the plowed field is where the thermals will lie. They will break loose at that point. The surface materials is very important. If you're looking for softer, sweet conditions, certainly don't fly over rock outcroppings and dry dirt plowed fields. Fly over a golf course. Land in a bright green grassy park. And that's a good point. If you're trying to land in midday strong conditions, certainly try to find yourself what we call a cool field as opposed to a hot field. Mountain flying is particularly complex. As a day progresses in the mountains, you can have what was a valley flow moving down valley as what's called a katabatic flow, cool air flowing downwards, switching almost abruptly and starting to blow upwards in an anabatic flow. The nature of how a valley works is that quite often the area closest to the ground has the strongest winds because of a Venturi effect of these flows of anabatic and katabatic flows moving quickly through the narrow passages in the lower parts of the valleys at the base of the mountains. But another aspect to mountain flying that's particularly important is that you have a mountaintop that may reach, let's say, 12,000 feet. And if you're launching at higher elevations and that particular elevation has full-on sun exposure, you could have heating accumulation on the slopes around your launch area or slightly below your launch area that are quite excessive. And so if you have a lot of heating accumulation there at 10 or 11 or 12,000 feet, you have to keep in mind that just slightly higher than the top of the mountain can be that region of cold air. It's not uncommon in Telluride or Aspen for me to measure on the slopes on those mountains temperatures of 100 degrees in some of those scree fields. Yet at 14,000 feet it could be 25 degrees. And that's a really severe temperature differential. And it's not uncommon in the mountains for pilots to report very strong, dramatic thermal releases. In addition, whenever you fly in the mountains, if the winds increase, you want to be very careful that you stay away from the lee side of a mountain. And we don't want to fly in a combination of wind and thermals, because in that situation we get more severe turbulence behind the thermals themselves. And features, flying through features closely requires an attentiveness to staying out front and to not being blown around the edges of the feature. All right, now that we've looked at overall wind, stability, terrain, and skill, we can decide whether to fly. Again, look at your regional weather maps. Study the jet stream, the lows and highs, and the isobar maps. Look at your barometer. It tells you the trends. Find out from the Weather Service what the upper level winds are doing and the temperatures aloft. Take a look at the stability of the air mass. Is the barometer dropping? Is it cold upstairs? And that means that we're going to have less stable conditions. Is the terrain that you're flying on forgiving? Are they nice, round, grassy hills? Don't accumulate a great deal of heat? Or are they very tall, sharp-edged, heat-accumulating mountains? The skill that you have. Have you been flying recently? Are your skills at identifying changing atmospherics as well as your ability to manage the aircraft you're flying all in line with the conditions that you're choosing to fly in? This information that we've tried to relay in this video will help you decide whether or not you can fly with confidence. And flying with confidence is really exciting. You're in the air, you trust the atmospherics, and you can make the best of it. Flying lucky isn't really that much fun. You wouldn't do that driving a car. You wouldn't intentionally drive a car at high speeds on an icy road. You'd back off or maybe not drive at all. Treat your flying the same way. You'll have a much more rewarding experience. You get to fly a lot longer. It'll be a lot more fun.